In this video, we learn how to compute the equation of the least squares line. For example, consider the following table, which shows the median heights of boys ages 2 to 14. In part A, we're going to find the equation of the least squares line. To do this, we're going to need the means and the standard deviations of the ages and the heights, and we're also going to need the correlation coefficient. We can compute these quantities using StatCrunch. To find the means and the standard deviations, go to Stat, Summary Stats, Columns. Hold down the Control button so you can select the age and the height. You can also hold down the Control button to select the statistics we want to compute, in this case the means and the standard deviations. To compute the correlation coefficient, go to Stat, Summary Stats, Correlation. Hold down the Control button, select the age and the height variables, and press Compute. So now I have the sample means and sample standard deviations and the correlation coefficient, and I can paste it into my workspace. And now we're ready to begin part A, which is to compute the equation of the least squares line. The slope of the least squares line is given by the correlation coefficient times the standard deviation for the y variable divided by the standard deviation for the x variable. In this case, the correlation coefficient is 0.99613. The standard deviation for the y variable is 9.49675. And then we divide by the standard deviation for the x variable, which is 3.89444. Do the arithmetic on a calculator, and we come out with a slope of 2.4291. We can calculate the y-intercept using the formula, the mean for the y variable minus the slope times the mean for the x variable. The mean for the y variable is 51 minus the slope we just computed, 2.4291, times the mean for the x variable, which is 8. Perform the calculations and we end up with a y-intercept of 31.5672. Now we have an equation for the height. It's equal to the slope, 2.4291, times the age plus the y-intercept of 31.5672. This is the equation of the least squares line. In part B, we're asked to interpret the slope of the least squares line. The slope of 2.42 means that the boys are growing at a rate of 2.42 inches per year. In part C, we're asked to use the least squares line to predict the median height of a 9.5-year-old boy. To do this, we put the height of 9.5 into the equation for the least squares line. Height is equal to 2.4291 times 9.5 plus 31.5672. Put this into a calculator and we obtain an answer of 54.6936 inches. In part D, we're asked to create a scatter plot. For this part, we can use StatCrunch. To create the scatter plot, go to Graph, Scatter plot. Select the explanatory variable, age, then select the response variable, height. If you want to see the graph of the least squares line superimposed on top of the scatter plot, select Overlay a polynomial of order 1. So a first degree polynomial is a line, and then press Compute, and now we have a scatter plot of the age height data with the least squares line also on the graph. StatCrunch can actually do all of this at once. It can find the equation of the least squares line. If you want to go that route, then you can go to Stat, Regression, Simple Linear. Select the explanatory variable, age, and the response variable, height, and press Compute. And now we can see that we have the equation of the least squares line, 31.567 plus 2.4291 times the age. If we move over to the next graph, we have the scatter plot of the age height data and the least squares line plotted on the same axes.